In this video, we're going to show the connection between the LCM of A and B and the GCD of A and B. LCM is the least common multiple of A and B in this case. The GCD of A and B, the greatest common divisor of A and B. This theorem states that if you multiply the LCM of A and B by the GCD of A and B, out comes AB. Let's go ahead and prove this. That is, after all, what we do on this channel. I prove theorems after lemmas, after some more lemmas, etc. If you like videos like that, most definitely subscribe to my channel, hit the like button, and leave a comment. Definitely hit the like button and subscribe. So we're going to define D to be the GCD of A and B. Have to start somewhere. Well, that implies that D divides A and D divides B. But that tells us, this here tells us that A is some multiple of D, and this tells us that B is some multiple of D. Now, I'm going to let M equal AB over D. Now, for the record, that means that MD is AB. Well, if this is the GCD, and we multiply it by something and we get AB, then M of A and B must be the least common multiple. So that's what I want to show, is that this here is the least common multiple of A and B. First, I want to show that it is a common multiple. Let's not get ahead of ourselves. Now, this here implies that MD is equal, well, actually, it implies that M is equal to any old way of writing A over D, well, AB over D, which is equal to RB, and A times any old way of writing B. A times B. Just wrote B differently. It's ASD over D, except I said it, I think. B equals SD. So let me put SD. The D's cancel out and I get AS. That is, M is BR and A times S. Well, that implies that M is a multiple of A and B. So multiple of B, M is, and M is a multiple of A. M is a multiple of A and B. We're getting somewhere. Now we need to prove that it's the least common multiple. So what you do then is you let C be another common multiple of A and B. Okay, so then C divides A and C divides B. That implies A is some multiple times C and B is some multiple of C. A equals UC and B equals VC. There also exists by Bezout's lemma X and Y in the integers such that D, the GCD of A and B, is AX plus BY. Now, if M goes into C, that means M is less than C. And that would imply that any arbitrary common multiple of A and B is less than C. Just want to show that this is an integer. That would imply M is less than C, and we'd be done. So this is equal to C divided by M. And right here, we said M is AB over D. Well, that's the same as CD over AB. And D, I can write that way. It's still C times D. Just going to write D differently over AB. I will distribute. I get CAX over AB plus CBY. CBY over AB. Here the A's cancel, and here the B's cancel. So C over M, coming from here, is C over B times X plus C over A times Y. Well, this here tells me, I did this backwards. A is a multiple of B. A is a multiple of B. That means C is A times U, and C is, that's not a U. A is C is A times U, and C is B times V. Well, this here implies that C over A is U, and this here implies that C over B is V. So C over B is Vx plus C over A is Uy. This is an integer. It's a positive integer. Yes, it's a positive integer. That implies that M is less than or equal to C. But that implies then that the least common multiple of A and B, well, M was a common multiple of A and B. But it turned out that it's even the least. So now we have this. And we started off with this statement right here. M is equal to AB over D. So M is equal to AB over D. That's the same as MD equaling AB. But M, as it says so right here, is the LCM of A and B. Times D, somewhere we said way at the beginning that D is the GCD of A and B. So D gets multiplied by M, which is the GCD of A and B, and AB is just AB, and since this is what we wanted to show, it's done. Like videos like this, hit the subscribe button, hit the like button, leave a comment. Now, I want to talk about this a little bit. You should know that if X times Y equals Z, that implies that X is, say, Z over Y. That means that the least common multiple of A and B is AB over the GCD of A and B. This here also implies that Y is Z over X. Okay, that is the GCD of A and B. X, Y, Z. X times Y is equal to Z. Now I'm saying that Y is Z over X. Y is Z over X. This one is probably Actually, this one is probably more powerful, because it's easier to find the GCD because the GCD is always smaller than or equal to A or B. LCMs can get crazy large. So what I'm getting at is, if you were asked to find the GCD of, I don't know, 4 and 6, or the LCM of 4 and 6, even if you were asked to find that, okay, what is that equal? I wouldn't do that. Actually, I apologize. If you were asked to find the GCD, why am I confused? Sorry, third time. The LCM of 4 and 6, this is A times B over the GCD of 4 and 6. This is 4 times 6 over, well, the GCD of 4 and 6 is 2. 2 goes into 4, so this is 12. The LCM of 4 and 6 is 12. And of course it is. So multiples of 4, there's the first few multiples of 4, the first few multiples of 6. Look at that. Not only is 12 a common multiple, it's the least common multiple. It's a lot easier to find the GCD. So again, if somebody asks me, what is a common multiple of 27 and 36? I have two choices. I can write down the 27 table, I can write down the 36 table, look for a common number. Or I can say it's 27 times 36 times the GCD of 27 and 36. Well, I know that 9 goes into 27 and 9 goes into 36. And actually, that's the largest number. So this is 27 over 36 over 9. 9 goes into 36 4 times. 27 times 4, you may have to work out, but it's 108. That's a lot easier, in my opinion, than going 27 times 1, 27 times 2, times 3, times 4, times 5. And 36 times 1, 36 times 2, 36 times 3. Oh, there it is. Now this wasn't so bad. I had to only multiply 27 by itself 3 times and 36 by itself. Let's try that again. 27, I had to multiply by 4. 1, 2, 3, 4. 1 time, 2 times, 3 times, 4 times. And 36, I only had to multiply it by 1, 2, and 3. So 7 multiplications if you didn't know any. And of course the first ones are easy. 27 times 1 is 27. It's a lot easier to find the numbers that go into 27, 36. 27 is 3 times 9. 9 is 3 times 3. So 27 is 3 times 3 times 3. 36 is 4 times 9. 4 becomes 2 times 2. I circle the prime numbers like 2 and 2. And 9 is 3 times 3. So this is 2 times 2 times 3 times 3. I look here, I look here. I look for what they both have. Well, they both have a 3. Ooh, they both have another 3. That's all they have in common. And 3 times 3 is 9. That is how I got the 9. Well, that's one way you can get the 9. I rather make numbers smaller. Here, I have 27. I deal with 3, 3, 3, and 9. 36, I deal with 4, 2s, 3s, and 9s. Over here, the numbers are getting bigger and bigger. I'd rather find the GCD than the LCM. And here is the rule, at least for 27 and 36. The LCM, via this theorem, the LCM of A and B, according to this theorem, is AB over the GCD of A and B. Because this product, namely GCD of A and B, times this LCM of A and B, is supposed to equal the numerator. And that is true. This statement and this statement are the same. Some students may say 7 times 2 is 14. Others may say 14 divided by 2 is 7. Or 14 divided by 7 is 2. Okay, this statement, actually all three statements are the same. They look different, but they say the same thing. If somebody likes to think in division, they may say this statement. Somebody, like most of us, prefer multiplication, they'll say this statement. They're called equivalent statements. They say exactly the same thing. If somebody asked me what 10 divided by 2 is, and maybe I'm extremely tired, I would ask myself, 2 times what is equal to 10? And I'll say 5, and there's my answer. You know, somebody asked me what 12 divided by 3 is. 3 times 4 is 12. So, you know, knowing your multiplication table is good for division. Now, it's one thing to know that 3 times 5 is 15. Okay, so that you came up with. But it's another thing to know 3 times what is 15. And you say 5. Okay, you should be able to do that. Then you can do division. Subscribe to my channel, leave a comment, hit the like button. Most of all, see you guys in the next video, and watch and learn.